Greetings, scholars. This is part 8, review for your final. If you look at your formula sheet, which, by the way, your formula sheet is on Google Classroom, is an attachment that is on the assignment for test, okay, final exam. So please make sure that you have that open when you're taking your exam. This part 8 deals with the kinetic theory of gases. If you look at your equation sheet, you will see something that looks like this. And let me just tell you that 1/2 mv squared, you know that that is kinetic energy in general. Try not to get upset by that little bar right there. Okay, that just means root mean square, which is a statistical average of the overall velocities of each of your particles. 3/2 kBt. Okay, I'm going to break this down a little further for you. So what ends up happening is that equation will kind of simmer down into this, which is, this becomes your heat energy is equal to 3/2 nkt. First of all, T is temperature. What is the scale for the temperature? Go ahead and answer that question now. So yes, this scale should be in Kelvin. All right, so my next question for you. How do you get from Celsius to Kelvin? I want you to explain that to me now. Okay, so if you did not get the answer right, you know that to get to Kelvin, you always take your degrees Celsius and you add 273, and that equals your temperature in Kelvin. Make sure you understand that. Next question. What in the heck is this N? What the heck does N stand for? Go ahead and answer that now. Number of molecules. You may remember the little n. Okay, the little n is number of moles. But in this equation, the big N, okay, is your number of molecules, or we'll say the number of particles that they are referring to explicitly on here. Finally, what in the heck is this K value? I don't expect you to know that. It is actually on your equation sheet. It says Kb. And that is called your Boltzmann constant. Let me write that down here. Here you go, K. It's the Boltzmann constant. It's 1.3806 times 10 to the negative 23. So I'm going to give you a little problem really quick. You're going to solve it, and then you are going to be able to take that and apply it to perhaps a slightly different situation that you might happen to see on the exam. Okay, so imagine that you have a question and I said, hey, you've got 6.07 times 10 to the 21 hydrogen atoms in this container, and they actually have an energy of 36.98 joules. Question, can you tell me what temperature these little objects are at? So the first thing that I like to do is I like to go ahead and isolate the variable you're solving for. I mean, to me, that just means manipulating the equation. So I would like to multiply E times 2/3, which is the reciprocal, right? And then I like to divide by the other stuff. So I will go ahead and divide both sides by N and K. And that's going to give me my temperature. You know what's kind of interesting is does that give me my temperature in kelvins or Celsius? So go ahead and answer that question right now. There you go. Will this temperature be in Kelvin or Celsius? So answer that now. So your answer is actually going to be in Kelvin. You will have to convert back to Celsius. Let's go ahead and solve this problem together. Please get your calculator out. You will need your calculator to solve this. I'd like for you to go ahead and start calculating right now. Pause the video. Now I will start to set everything up. Oh, red is so dark. Okay, my energy 36.98 divided by my N, which is E21. Okay, divided by my K value, which is 1.3806 E negative 23. Okay, and that's going to equal my temperature. Oops, there we go. Okay, if you haven't stopped yet, go ahead, take the time to plug in. Okay, I plugged everything in, and I got from my final answer that the temperature is 294. Whoa, problem. That is Kelvin. So I want you to take this time right now. Answer this question now. My final answer is 294 minus 273. And what is your answer? 4 minus 1, 3 is 1, 9 minus 7 is 2. So your final answer is, I guess I'll just move it over here. Okay, it's 21 degrees Celsius. I want you to be able to apply all of this information that you know, okay, to any questions that you might have in the exam. Yay!